Welcome back to The Deep Dive, your shortcut to being well-informed. Today, we're diving deep into Fortinet. We've got quite a stack of sources here, articles, research really digging into what it can do and how it tackles, the big security headaches with everyone working everywhere these days. Our mission, to unpack all this and give you a really clear picture of what Fortinet is and honestly why it matters so much right now. But first, to really get Fortinet, we need to talk about the bigger picture it fits into, SASE, Secure Access Service Edge. It's more than just another tech acronym, right? It signals a pretty major shift in how we even think about security.
Oh, absolutely. You've hit the nail on the head. SASE is a fundamental move away from, well, that old castle and moat idea of security, the traditional perimeter. Instead, it's about a unified service delivered from the cloud. Imagine bringing together all your networking and your security tools into one thing. And the real beauty of it is how much it simplifies managing security. Plus, you get consistent protection for your users, your apps, your data. It doesn't matter where they are.
That idea of unified and cloud delivered is huge. I mean, for years, companies had to stick dedicated security boxes everywhere, right? Every office, maybe for different user groups. It must have been a nightmare to manage. Complex, expensive, just a web of different tools. Okay, let's unpack this. How does a cloud-delivered model like Fortinet actually fix the problems of that old hardware-heavy approach? What specific headaches does it cure?
It's a total rethink, really. That old way, managing all those scattered hardware boxes, it just became unsustainable, especially with people working remotely, apps moving to the cloud. The whole idea of a network edge kind of dissolved. Fortinet simplifies things massively by pulling all those separate functions, firewalls, VPNs, web filters, you name it, into one single cloud service. It streamlines everything for IT teams who are already stretched thin. And it gives you truly consistent security everywhere. Plus, it scales way better, handles fluctuating needs, and actually improves application speed for users. No more patching dozens of different boxes or trying to keep policies in sync.
Yeah, that makes a ton of sense. So drilling down into that cloud architecture, when we say Fortinet gives secure global network connectivity and security services wherever users are, how does that actually work? Sounds complex.
It is sophisticated under the hood, but the way it works for the user is pretty elegant. The key piece is the Fortinet POP. That's point of presence. Think of POPs as a global network of Fortinet data centers or nodes. They're spread out strategically. So when a user connects maybe from a cafe, maybe their home office, they're not sending traffic all the way back to corporate headquarters. No, they get them to their nearest Fortinet POP. And these POPs are built to deliver both the secure connection and all the security checks right there, close to the user. It cuts down latency, improves the experience, and keeps security consistent.
Ah, okay. So that closeness, that POP proximity must be a big deal, especially with cloud apps. Here's where it gets really interesting. What's the biggest advantage of doing it this way, cloud delivered, compared to the old methods, beyond just making management simpler?
I'd say the truly transformative part is the agility and the consistency it brings. With the old hardware model, scaling up meant buying and deploying more boxes. Slow, expensive, cloud-delivered SASE. You can scale capacity up or down almost instantly based on need. But even more important is the consistency. You get the same security policies applied to every connection, every user, every device, every app access, doesn't matter where they are. That closes security gaps you often found in those older distributed setups. And for the IT admin, they manage it all from one place. Huge reduction in workload. Frees them up for other things.
So what does this all mean for controlling what people access and keeping data safe, especially now with data flying between SaaS apps, devices, cloud services? How does Fortinet help manage that flow?
It fundamentally changes how you secure that flow. And this is where specific features within Fortinet, like CASB, really shine. Cloud Access Security Broker. CASB is absolutely key for controlling SaaS and cloud applications. It's not just about blocking stuff, it gives you deep visibility into which cloud apps are being used, assesses the risks they pose, and lets you enforce really specific security rules. One huge thing it tackles is shadow IT. Users signing up for random cloud services without approval. CASB spots these unapproved apps. Then, administrators can decide, block it completely, or maybe allow it but restrict certain actions. Like maybe you can use an approved cloud storage, but CASB stops you uploading sensitive files there. Or use a chat app, but block file sharing within it. It's strategic risk management.
That's really granular. So thinking like an admin, if I want to stop users accessing, say, unapproved file sharing sites, I'd be looking at enabling CASB policies specifically for that.
Exactly. You'd configure CASB policies to identify those unapproved applications or categories, and then set the action to block. It's the tool for that job.
Okay, so CASB handles the apps, but what about protecting the actual sensitive data itself, preventing leaks?
Right. That's where data loss prevention, or DLP, comes in. It's another core piece of FortiSASE. DLP policies are all about monitoring and controlling sensitive data in motion, preventing confidential stuff from being shared where it shouldn't be. So, if an administrator needs to implement a security policy to block file transfers of sensitive data, financial records, personal info, intellectual property, DLT is the feature you'd use. It watches for that sensitive data and steps in to block unauthorized uploads or transfers. Crucial for compliance and avoiding costly breaches.
DLP is definitely critical, but I know sometimes organizations find it tricky false positives blocking legitimate work or policies being too loose. How does FortiSASE help admins walk that tightrope, especially with users everywhere? Is it just about blocking?
That's a really good point. Effective DLP is a balancing act. You don't want to kill productivity. FortiSASE helps because its DLP is integrated into the whole platform, and the policies can be very granular. Admins can define sensitive data, very specifically keywords, patterns, file types. And the enforcement isn't just block. It could be alert, quarantine, encrypt. And you can tie it to context, like maybe block uploading source code to personal cloud storage, but allow emailing it to a specific trusted partner domain. Because it's part of the unified SaaS platform, the same DLP policy applies whether the user's in the office, at home, or on the road. That consistency really helps reduce complexity and false positives.
Makes sense. Okay, let's switch gears slightly. How does FortiSASE handle access itself now that the old network perimeter is, well, gone? We hear ZTNA, Zero Trust Network Access, thrown around a lot.
We do, and for good reason. ZTNA is the modern approach, moving away from traditional VPNs. It operates on that never trust, always verify principle. Unlike a typical VPN that might give broad network access once you're in, ZTNA is much stricter. Access is granted per application based on who you are and the security state of your device. So that security posture check for a user's device, if main purpose in FortiSASE ZTNA is absolutely vital. It verifies the device meets specific security rules before it's allowed to connect to anything. It's pure zero trust. Only compliant, healthy devices get access. No compliance, no access. Simple as that.
This raises an important question. How does FortiSASE ensure devices are trustworthy before they even get on the network? What kind of checks are we talking about? Basic stuff, or does it go deeper?
It starts with the basics, absolutely. Like, is the antivirus up to date? Is the OS patched? Is the firewall on? Foundational checks. But a robust ZTNA solution, like FortiSASE's, can go much deeper. It can check if the disk is encrypted, if certain forbidden applications are installed, if required security certificates are present, even the device's location. It can also integrate with EDR endpoint detection and response tools to get a real-time threat score for the device. The trick is balancing tight security with not annoying the user too much. FortiSASE handles this with very granular context-aware policies. So a device failing a minor check might just lose access to super-sensitive data, while a device with major issues gets blocked completely until it's fixed. It's adaptive.
Adaptive, I like that. Now, security is one thing, but performance matters too. People need their apps to run smoothly. How does SD-WAN integration fit into the FortiSASE picture?
SD-WAN integration is where security meets network optimization. It's a really powerful combination. By integrating SD-WAN capabilities with FortiSASE, organizations get things like dynamic path selection and traffic optimization. Basically, it means your important business apps are not only secure, but they also run reliably and perform well. SD-WAN intelligently routes traffic over the best available path, so maybe your video call goes over a low-latency link, while background updates use a different one, all while FortiSASE ensures every path is secure.
Okay, so which of the following best describes the key benefit here? Is it mainly about saving costs, or is there more to it for the user?
While cost savings can be a factor, the key benefit of integrating SD-WAN with FortiSASE is really enabling that dynamic path selection for traffic. The direct result is optimized application performance and much higher reliability for the end user. Fewer dropped calls, faster file access, a smoother experience overall. And for the business, that translates to better productivity and resilience. If one internet link fails, traffic automatically reroutes. It lets you really lean into cloud apps without performance hits.
Got it. Okay, let's talk practicalities for the admins managing all this. Deploying security agents, setting policies. How do they handle this efficiently, especially in big organizations?
Deployment is always a big consideration. If you need to get the FortiSASE agent onto hundreds, maybe thousands of devices, doing it manually is just, well, impossible. The most suitable method, hands down, is using a corporate mobile device management, or MDM solution. MDM platforms let IT push the agent installation out remotely, enforce the right configurations automatically, and make sure security is consistent everywhere without touching each laptop or phone. It's all about efficiency and scalability.
Right, so if you're faced with deploying the FortiSAS agent to a large fleet of devices, MDM is the way to go. Makes sense. Does MDM help after deployment too, keeping things updated and compliant?
Absolutely. MDM isn't just for the initial rollout. It's crucial for ongoing management. It can monitor if the FortiSAS agent is running correctly, push out agent updates automatically, and check if the device stays compliant with security policies. For example, if a user disables their firewall, the MDM can detect that, maybe block network access, and alert IT. It ensures that security posture is maintained over the device's entire life, essential for zero trust.
Okay, switching to policy design. The principle of least privilege is fundamental in security. When an admin is setting up a FortiSAS policy for, say, a new team, what's the most important consideration for ensuring a least privilege security model? How do they start?
The absolute most important thing is to start with a restrictive policy that allows only the necessary access, then grant more permissions step by step as needed. Never start wide open and try to lock it down later. That's asking for trouble. You assume zero trust initially and only open the specific doors required for that user group to do their jobs. It minimizes the potential damage if an account gets compromised. Much stronger security posture.
It sounds straightforward, but I bet it's easy to get wrong. Where do organizations usually trip up with least privilege, and how does FortiSAS help avoid those pitfalls?
A common mistake is not reviewing policies regularly. Roles change, people move teams, apps get added or removed. If policies aren't updated, you get privilege creed people hanging on to access they don't need anymore. Another issue is creating policies that are too complex or overlap, making them hard to manage or even understand. FortiSAS helps because it offers that single, unified console. Policy management is centralized, and the granularity is key. You can base policies on identity, device health, the specific application, even the type of data being accessed. This lets you be really precise with least privilege. Plus, the ZTNA component means access is constantly reevaluated, not just granted once. This helps cache changes and keeps access appropriate.
Okay, last area. Troubleshooting. Things inevitably go wrong sometimes. If a user calls saying they can't connect with their FortiSAS agent, where should the admin look first?
First stop should always be the agent activity logs on the user's own device. Those logs capture what the agent itself is doing. Authentication attempts, connection efforts, specific errors it encountered. It gives you the ground-level view right at the source of the potential problem.
Yeah.
Much easier to pinpoint the cause that way.
Right, start at the endpoint. And what if the issue is different? Say a user complains a website they need is being blocked. Which type of log would an administrator use in FortiSAS to investigate that blocked website attempt and figure out why it was blocked?
For that, you'd go straight to the security logs within the FortiSAS Management Console. These logs track all security-related events, things blocked, threats detected, policies triggered. When a website gets blocked, the security log won't just say denied. It will give you the details, the site's category, maybe its risk score, and crucially, the specific security policy that caused the block, like web filtering or threat prevention. It tells you the why. That detail is vital, not just for fixing that one user's issue, but also for understanding if your policies need tweaking, maybe identifying a false positive or spotting risky behavior patterns. And maybe a final thought for you to ponder. As cloud apps keep evolving and remote work isn't going away, how might these SASE principles change more than just security? How could they reshape the actual structure of IT departments? Will we see network and security teams merge completely? What skills will be needed? Definitely something to keep thinking about as this shift continues.